said it's not.
We did this but you were last week. We did last week 2, 3, 4, 2.
Grace, not here. All right, I need y'all to clear your desk off for the quiz. Addison, Elise.
I don't suspect you're ready for this.
Here to advise your mom.
I mean, it's just a 2-question thing, but I knew that it's gone off. I didn't have to even do that.
Happy birthday.
Okay, like we've been doing, if you would please just turn it face down when you're finished, and I'll come and collect it from you so you don't have to. I'll get up and then be distracting each other, and it helps me keep up with about how much more time we need, so. All right, so this one ends up being 2 points too. The second point will be either right or wrong, but the first point, half of it comes from the correct answer, and half comes from a justification. waiting on any others. Okay, so hopefully you thought this was the easiest one yet. I certainly feel like it was the easiest one thus far. But this is a B week, so we'll only see you guys one more time this week. So today we've got really 3 things I want us to achieve. One is, one handout that you picked up is 118. It's the one that says derivative of inverse trig functions. So these are the ones that you need to have memorized for your AP exam. When they have shown up on a couple of worksheets in the past, I have just had you write down on the top of the page, and I said, you don't need to memorize these yet, don't worry about it, I won't put it on any test or anything like that. But this 118 is what your mini quiz will be over next class. Now, a couple of these are more important than others, so I'm going to structure your mini quiz the same way. So you need to write this down for these 2, or for all of these, I guess. But the most important 2 are going to be inverse tangent. In fact, you may know that one now because that's the one I have to tell you occasionally for some of our circuits. These 2 you need to be able to answer as short answer. So it'll just be derivative of inverse sine is blank, and you have to be ready to write that out. Another question on your mini quiz on Wednesday will be what's the derivative of inverse tangent, and you need to be able to write that one out. These are the 2 that are the most common by far on the AP exam, but I can't promise that they won't put any of the others on the AP exam. So for your mini quiz, the other 4, these 4 will just be matching. So you need to be able to recognize them well enough that you can tell me which one goes to which. And it will be 4 questions, 4 choices. I think. Yeah. 4 questions, 4 choices for these 4, so you just need to be able to match them up. Now, there is a lot of pattern between these. Now, again, if you want to be 100% sure you get all of these right on the AP exam, I guess you have to memorize all 6. But based on release stuff, it is almost always inverse tangent, occasionally inverse sine, and almost never any of the other 4. But there are a couple quick things that you can take note of. Like if you take the derivative of anything that starts with a C, those are the ones that are negative values. Inverse sine and inverse cosine almost have the same derivative, but the cosine one's negative. Inverse tangent and inverse cotangent are almost the same, but the inverse cotangent one is negative. And the inverse secant and inverse cosecant are almost the same, except the inverse cosecant is negative. So it's not like there's really 6 things to memorize. It's like memorizing 3, knowing which ones match up with each other. The ones that start with the C are negative, the ones that don't start with C are not negative. So, all right, so just kind of a review question for those of you that did pre-cal last year. Does anyone remember that connection? What we said, sine and cosine have a connection, tangent and cotangent have a connection, and secant and cosecant have a connection. Does anyone remember that name? Starts with the C.
SOHCAHTOA? Coating.
Closer. These were the co-functions. If you remember the co-functions, sine and cosine were co-functions, tangent and cotangent were co-functions, and secant and cosecant were co-functions. So that's one of those identities we had you memorize in pre-cal. Not this, of course, but those co-function things. And they're kind of helpful with graphs a little bit, but if you still remember that connection, that's how you can remember which ones pair up with each other. Completely optional. But what I need you to write down and what I need you to learn by Wednesday is you need to memorize inverse sine, be able to answer what it is as a blank, and inverse tangent the same way. The other 4 will just be matching. You just need to know those well enough that you can identify which one's which. So, any question about that? Okay. So that is what the mini quiz will be over. And I guess from here on out, when inverse derivative of inverse tangent comes up, I won't forewarn you what that is, because you should know what that is. All right, the other two things I've got on our agenda, we're going to finish class with that 114, the circuit volumes of rotations. So when you guys were finishing up class last time on that, I know some of those, the radius of some of those questions were a little harder to come by. So I wanted to offer a little bit more help there. But before we do that, 119 is the other handout that you picked up today. And this is a continuation / extra practice from what we did on Friday. It's the same exact thing. I just think that you need more practice on it. So this is when we had known cross sections like squares, semicircle, equilateral triangles, or isosceles triangles. We wrote those formulas in terms of their base. And then really, we just integrated the area as a way to add up an infinite number of those shapes, and adding up an infinite number of areas tilted on their side gave us the volume of the three-dimensional shape that would create. So let me give you a couple quick reminders here, and then the next part of class I will let you work on these and get a little bit more practice under your belt. I do also have something I want to show you, like an online visual, so because my pictures here I know are not good. But you have to remember these formulas. So of course some of these are a little bit easier than others. What did we say we would use for the area of each square in terms of the base? Okay, so base squared. I feel like that one's not too bad. Semicircle, personally, I would do 1/2 pi r squared, but r is different than the base, so if you're going to do that, just make sure you're doing r, the radius, not the base length. Does anyone remember what it was in terms of the base? What did you say? Okay, 1/8 pi base squared. Base is going to be the thing that's on your paper, the part in the XY plane, not the part sticking up. Okay, I'd say probably the next easiest is equilateral triangle. Anybody remember that one? Very good. Square root of 3/4 base squared. And then these two always kind of trip me up because I don't get to use them outside of this one lesson. But isosceles right triangles, but if the base is the leg versus if the base is the hypotenuse, they're both pretty similar, but they're not the exact same thing. This one is 1/2 base squared if it's just the leg, and if it's the hypotenuse, it's 1/4 base squared. So last class, I even derived these for you so you can see where they come from. You don't have to know how to derive them, but before we get to your last big test of the semester, and of course before the AP exam, you do need to memorize these. So I still don't know the date of our last unit exam, but I will give you some warning on it, of course. Okay, so again, even though this is kind of hard to visualize, at the end of the day, you basically just integrate area. So if you know those area formulas, you just plug that in, integrate from x to x if it's dx, perpendicular to the x-axis, integrate from y to y, dy, if it's perpendicular to the y-axis. Although all of these today look to be to the x-axis. Probably should change one of those, but okay. And then just one more little reminder here, and then I will let you try some. And like we did on Friday, you don't have to do the integration by hand. In fact, a lot of this would be pretty messy. But I want you to write down the integration that you do, put it in a calculator to get a decimal answer, and I will share some of my decimal answers so that you know if you're doing it correctly. Okay, so when I see this, the cross sections are squares, I know I should be integrating b squared. That's the area formula. You just integrate area. Try not to overthink it. Since it's perpendicular to the x-axis, I know it's going to be dx, and I know these are going to be x values, and this needs to be in terms of x. So for this first 4 questions, it's a circle centered at the origin with radius of 5. So that equation would be this. Since it's at the origin, you don't subtract from x, you don't subtract from y, 0, 0. And for the radius to be 5, the other side needs to be 25. So even with my pretty sad picture here, I can see the x values go from -5 to 5. Or, by the way, and I'm not going to do this just because I want to simplify the process for you, because of this symmetry, like how there's just as much on the left 2 quadrants as there is from the right 2 quadrants, instead of integrating from -5 to 5, you can, I don't know why you would, but you could integrate from 0 to 5 and then double it, because it's got that symmetry to it. So, okay, and then finally we need to think about what the base length would be. So again, you might want to try to make some pictures here, but here's the square. This bottom part is the base. This is the part that's, you know, on the flat surface. The rest of this that I'll put in blue is the stuff that's sticking up in the air, making a 3-dimensional shape. Any cross-section square that I put perpendicular to the x-axis, again, this stuff is up in the air, I can see that the base length is from here to here and here to here. This is what we would call y. This is what we would call y. The base is 2y. But we need these variables to match. If this is dx, this should not say y. So instead of saying y, you need to go over here and you need to solve for y. Of course, doing the picture and solving for y, you really only have to do this once, and then you get to use it for all 4 of these. So, looks like y is the square root of 25 minus x squared. So if you throw all that in your calculator, it comes out to be approximately, it's a decimal, 666.667, actually 6.666, I think, repeating. And since it's a volume, we should probably start making sure we do the units correctly. Just like area is always squared, volume is always cubed. So I'm going to put units of units cubed. Okay, so last one, I'm just going to start you on. The only difference with semicircle is it's still perpendicular to the x-axis. All that's different is the formula is different. For semicircles, you could do, well, either one of those, but you better be careful if you do it the way I do it. 1/8 pi base squared. And if you've already thought about what the base is up here, then you have this one ready to go too. Your calculator would type all that, have your calculator do the integration just for time purposes, but it should come out to be that. So all you're changing in each of these questions, or each of these 4, is just a different area formula. Integrating the area gives you the volume. Okay, so go ahead and try the other 2. I will jot down my answers as a decimal. So that way you know if you need to stick with it or ask me for some help. And then there's 2 more sets on the back. So this is pretty much the last good practice I have of this skill. Again, this is one of those skills that I know often feels kind of uncomfortable, but once you memorize the area formulas, you're just integrating area, and you just need to be careful about what the base length is. Because the base could be y, the base could be 2y. You really need to force yourself to draw a little bit of a picture if possible. So go ahead and start on that, and then after a few minutes I will slide my paper up and share some of my decimal answers on the back page so that you can check those as you go on. And I will grade these quizzes. Now normally I would pass back your mini quiz from Friday, but my B-Day class won't take it until tomorrow, so you'll have to wait one more day for that one to get back. I need them to have a chance to take, even though I have a makeup form, I need most of them to take the form ABC, so I need to wait a class period there. And of course, you guys are welcome to work together and help each other, but please do yourself a big favor, and the ones that you miss or make a mistake on, try to write yourself a note about what your mistake was. If you guys look back at this in 2 weeks and you look at the work I have on my board, that's not going to help you remember where you struggled. You're basically going to have to start over from scratch as far as the study ends. So. And again, there is a couple small things I need to still show you, kind of like those derivatives of inverse trig functions. But this is really the last of the major new topics, the last of the questions that take a lot of practice to feel comfortable with. Oh. What?
He was asking why you multiply by 2.
Oh. I didn't know if you were talking to me or about me. Yes?
Grace is being a distraction to the class.
Grace?
Could you remove her?
No, I'm not going to remove her, but... Okay, also, if you want to play around with this, just so you know that it's here, I'll put this back in a second. But on our class website, if you go down to this, one of the links says interactive tool to help you visualize the volume from cross sections. So this is, I don't know who made this,
Yeah.
But basically, if you have,
I'm not gonna use it.
you know, here's like your base, the part that's on the piece of paper, and then if it cross sections were squares, you can see what one square would look like, and then as you make more squares, do you see how it comes a 3-dimensional shape? Here it goes further. So, when you're doing cross sections that are squares, you're just finding the area of one of them, but the integration makes it where you do an infinite number. So this is only 8, and you can already kind of see the 3-dimensional shape. If you do a bunch of squares, it doesn't take very many. There's 100. You can see the 3-dimensional shape you're finding the volume of. But again, it's really just a bunch of these squares, infinite number of squares being added together. But then you can also change it to like see, here's what it looks like with equilateral triangles. So again, if you do too many, it's kind of hard to even see them, but there's equilateral triangles. So when you put enough of them in there, it's not the exact same 3-dimensional shape. It doesn't have the exact same volume, but this little tool helps you play with all that stuff. Here's what the semicircles look like. One semicircle versus a couple semicircles versus almost infinite semicircles. A little more curvature instead of straight. So if you're like me and these are kind of hard to visualize, again, I linked this little internet tool on our class website right here. So if you're trying to wrap your brain about what we're trying to find as we do this, that is an option. Okay, there's my decimal answers back up for page 1. Obviously, once you feel okay with those, keep on going to the back page. The sooner you do the back page, the sooner you can move on to that other circuit and potentially have less homework. I will eventually move my answers to the back page, so you can try them and check them once I do that.
So it's saying the length is on the base, so it's like a curve like that.
That's at 80.
This is the length, and the height is like 4, which is the size like this way. So if you just multiply the kind of function, like a distance to the
I have a question.
Okay.
For this one, would you subtract them?
Well, I would visualize what those graphs look like.
It's like
Yeah. So the area between those, you got to think about top minus bottom. Top minus, yeah. So then that ends up being the base.
Mr. Thompson,
Yes.
do you have the answers for the back page?
I will start to write them down. Okay, if you're still working on these 4 that are up on the board, that is fine, but please jot the answers down out to the side, because I can only leave up one thing at a time, so I'm about to switch it.
Just a diagonal, and that's the length.
Okay, this is what I got for number 2 when you get there. And these are rounded to 3 decimal places. This should be exact, yeah. Well, rectangle is length times width. So this is like this is your length, y, times your width, which is 4. So your area is 4 times L.
Yeah.
Okay, so what's the problem?
My area is 4 times the biggest one you got.
Well, my answer is for the volume. What? Oh, I see what you're saying. You multiplied it down there. Well, in this case, I think you shouldn't be squaring that one.
Oh.
Because the area is 4 times L, not 4 times L squared.
Okay.
Yeah, it's just that much stuff.
I just put in the calculator and calculated for the Yeah, 4.36 and negative 0.2. Yeah. I was about to say 5. We did that for all of these.
Wait, so what's the base?
Okay, in just a minute, I'd like to slide this up and show my answers to number 3. So,
I had
It's fine if you're not done with number 2, but you should jot the answers out to the side so that you know if you're finished with them or not later. I'm gonna leave this one up for just another minute.
It was bleeding. How did you find X? The two X's?
Just put it in the graph and you can do segment.
Where's second?
Okay, I slid it up for my question 3 answers for those of you that are already there.
You guys get 140. Why did you guys not Oh, I plus 6.
Came to drone here, then you know it's that.
Are you cute?
This is the devices that they send us, and they've been used for.
This is a big one. All of them are outfield and that was like so dark. Because Who's the first one? Who's the first one?
The first picture.
Oh.
First picture, yeah, it was better than the first.
Oh, do not be squirrely.
All right, I have those graded and in the grade book, so I'll come around. If there's any of these you had trouble getting the same answer as me, just let me see your work and I will try to
I did that, but then
You checked it? Bottom one? What about the third line of the revolutions or rotations one? I haven't asked you to finish that yet. Y'all have any of these I can help with? You already know how to do it, you weren't even here last week.
Oh, I did like the Khan Academies for the.
Oh.
I did those at home.
Well, the Khan Academies don't match this, so. The Khan Academies were always circles, pi r squared.
I did the three that helped out. I'm not sure what we were saying, but yeah, I wasn't sure what the
It's hard to tell. If you see it, I don't know if you ever seen that minion over there in the corner. But that was a whole project they used to do. Someone made a minion and they did the volume of those semi-circle.
I have to check my code in the trade book.
So first I was going to do about me, and then is it in the calculator?
And then it's calculated for zero.
I don't know how to do it like that.
Are we gonna like be able to do that on the session? Find out everything.
it's kind of repetitive. Yeah, you kind of just have to figure out how to calculate numbers first, and then after that, you
I mean, technically, I did quadratic formula, and I had exact values. 2 plus the square root of 5 and 2 minus 2. But if you're doing 3 decimals here, but yeah, I think with no calculator, then these would have to be nicer. This needs to be something to do by hand. So they'll ask you to do that, but probably not like.
Can I circle one?
Well, it'll be graded for participation. It's not like a test grade. No, but that'll be like 4 nights of your homework. I'll split up the 4 different parts and ask you to do that. And then we'll look at some of the questions together in class. And it'll be easy to crash. And it's from like a real idea.
Structure this wrong. Yeah, to walk for the.
What sure is that seat? Here? Okay, so, well, first off, I tried to draw a picture here. Here's my picture. So the area on the bottom, here's the base. The base length is from the top to the bottom. So you're squaring each one. You don't need to be squaring each one. Top minus bottom tells you that length, and then you're squaring that. Y'all have one of these that you're stuck with?
I'm not sure.
No, the school, I think they changed it on some of the school calendars. I think it was originally the 15th.
I,
Was the school day off? Yeah, remember we added the school day, and part of it was we could either add 35 minutes to every day
and that's what she's been
and still get 2 more days off in a year, or we could add 30 days and go every day.
doing. Yeah.
So one day you got, we did the 35 minutes and you get 2 days off. First day you got off in February, President's Day. The second day would have been in April 15th or something, but there was gonna be so many teachers on for the eclipse day that they moved it to that. So it's really that 8th. Just the 8th.
Yeah, 0.
You done with this already?
I guess I got 22.
Okay. Oh, you didn't watch that yet,
Yeah, it's the
Yeah, definitely.
Or when you're doing, so you're always integrating the area of the cross section. When you're rotating something like these,
like the
volumes of rotations, it always creates an infinite number of shifts. So these are always piles. If it's a different shape, it's one of those. Okay, and then you have to be careful with R. R is the issue. When you, so this is the area that you're trying to rotate around this line, right? At this point, you'll draw about 2x around. So if you draw in a couple of these circles, you can see that R is kind of wide. You don't want to say wide because it says yeah, so you can go wide. That looks good. If you're doing it without a calculator, yeah, I would FOIL this and then undo the power wheel 3 times. But for this, just let your calculator. I mean, write down what you put in the calculator before you get to your answer. But if it's real basic, like I think number 1, I think you could integrate quickly. Yeah. There'll be time and place to practice on integration, but that's not the focus. Like focus of that is practice on
You add time with this.
That's part of the next round.
Oh, that's.
Well, this is kind of the same thing. You're integrating area and putting little circles. But R is hard to find.
Yeah. Are you gonna take the, I mean, I kind of need to know, because like, may have, they have the other number house.
So,
And then also tables.
96 squared, squared big R, that's like
Go yourself. So you, okay, yeah, I'll bring it up.
So here, your little R is this inside point, closest to the one you're trying to represent. So, it looks like your R is around. So if I plug in 2 here, so you see the next 4, which is and let's try, so right here, I think it's
Whatever.
okay, and then what about an x=0? Zero, you're saying it's the
Which one? It's gonna be, yeah, and then the X, so it's gonna be 6.
It would be 6 the whole time, minus
But why is horizontal?
I know. But your picture is good, so.
So would the base be X squared? Just 2 minutes.
Okay, alright, so that's good.
Why is this a wild line? How's horizontal?
Never done it.
Why value is an extra? Still on board. Yeah.
I might have one of those. So, yeah.
Yeah.
So I recognize both sides.
Yeah, no, it's just for each.
Okay.
Just for each skill.
So long. So basically
I remember when I was
Big value is big, like,
I
six.
finished the semester today. And I don't have
There's a
like,
dark
I got a deep, I think I could see
Send me an email to remind me. Because I don't remember what that was.
I'm going out charging mine to see if it was
Well, then send me an email. I'll read it.
and then drives me.
what do you do?
Okay. You have that one surgery from 2 classes finished?
Changes because there's
Okay.
subtraction.
That one? That one's pretty, has a pretty tough question. That's why I'm giving you more class time on it.
Sorry about that.
He spends every night buying pictures.
Oh, I just did what we've been doing here to get like the base, so just the top line minus the bottom line. So it would be similar to what we did here, a minus x squared minus x squared and then x squared. What does it mean?
All right, just a friendly reminder, you should be going back to handout 114 when you're done with this stuff from today. I did not make you finish 114 because I thought you had a handful more questions, so. I'm happy to help you if you're stuck. That's why I'm giving you some class time to do that. But if you don't have it finished, it's your last chance to get help from me on it. Actually, I'm going to put this up.
No, this is what it's for. This is just.
So it's choice, then it's a wooden double. I'm already double. Zero to two, zero to two.
Great.
This is x-axis because there's a horizontal line. They're taking the the line is four.
How did you set it up? I think we'll see the oldest class. What'd you do?
I'll stay up at this.
Because I did four squares mine out next to the floor. So I didn't get answers.
115.
I just didn't.
So it should reflect it. Wait, how do you scroll into the
No,
15.
but like,
I'm not
it's like the
67.
radius. Like this radius. 16 is 4. 0. 4 is 4. R squared 16.
Oh, you scored.
But I don't know the other one.
What's the other one?
Because I remember when we went over this thing, I forgot how we got to this.
It's times 4. Is it 17? What, on 18?
On 18.
Double what?
Because he added 2 to.
So you guys are divided as a whole.
Yeah, but I don't know how we got to this.
That's what.
2 plus 4.
Oh, yeah, I forgot that was on present.
One more thing. You're literally just throwing us so bad.
When is it due? Friday?
Wednesday.
Yeah, that's what I got. But that's not. Yeah, but it's not an answer on the sheet.
Yeah.
How's almost over?
I've never seen balls before. Thanks for all those stupid animals we'll give them. Mr. Townsend. Meet up, Spencer.
You need help?
On the circuit.
Okay, just a sec. Okay, I did just post some of my individual videos to this
Number 114 circuit. It doesn't have a video for every question, but it does have quite a few, so that might help you with some if you don't get to them in
How
class.
do you set up number this one? So we got the big radius of 16, but we don't know how to contact the other one.
What do you think the big radius is? Okay. And then the small radius.
I don't know how much, I don't know.
Okay, so
What is that?
sometimes the best thing you should do is write down what you think it is. So you're integrating, you think this is big R, and then what did you guess R, little r to be? X squared. Okay, so if you think this is little r, look at your picture. When x is 0, how big is little r?
0.
It is 0
Or, wait, just like.
on your picture.
X is 0. Radius is not.
It's what?
It's not 0. It is.
Okay, but what is it supposed to be?
Oh, wait, no, it is 0.
It is 0?
But X is equal to. It's like just.
Yeah, but you're rotating around this line, right?
Yeah.
Yeah, so it should be 4.
Whoa.
Well, if you plug 0 in here, are you saying the little r
Why
is
not
4?
start at 11?
Then that can't be correct for your little r. Okay, pick another value like maybe 2.
Yeah.
Does that come out to a nice whole number?
Wait. Wait, what are we going to do?
You're just rotating like this.
I'm just saying, pick one that you know the value for. So like right here, isn't this x equals 2?
If it's over here, then there'd be a 4, like right there.
Okay, so how big is that little r when x equals 2?
And here, there's not gonna be that.
It's 4. Or, yeah.
You'll need to be drawn.
It says maybe
If you're taking this point and rotating it around this line, you get something like that. radius is 4. If you're taking this point, trying to rotate it around this line, it's already there, so that's what we're going. Yeah, you need to make a habit of drawing a couple of those cross sections. So plugging in 2 here, you would be saying little r is 4, it's actually 0.
Wait, why is it zero? Oh, I just
So
didn't
are,
see.
because it's like there's no space, they're both the same color.
Yeah.
Where the rotated dial, they both have white
You gotta think of another way to express it.
Bro.
My answer
Is that what your answer is? Like 2.
Oh, I see.
They're both at white.
Yeah, yeah, that makes sense.
And you're rotating.
There. 32. Is it 32 or 33? That's what I'm working with. About that for 6.
I don't know if I'm right.
Okay, this is kind of what your picture looks like, right?
Wait.
So this has a radius of 4, right? This doesn't get to open up at all, so this has a radius of 0.
We can do now.
So you gotta come up with a different way to, x squared doesn't work.
5 of my numbers.
So what you're gonna have to do, you're gonna have to do this on several of the end questions. Probably
Wait,
start.
isn't the shaded portion bounded by the x-axis?
Yeah, especially rotate around the x-axis.
Or no, it was bounded by x-axis and then rotated around.
Yeah, so, yeah.
Y equals 4.
It's on the other side of
Oh, sorry. Doesn't matter, if you're still rotating, well, it does matter, but if you're rotating it around this line, when x equals 0, the small r is 4, when x equals 2, the small r is 0, when x equals 1, small r is 3, right? So how I would express this, and how you need to think of these harder ones, is that at most it's 4,
Really interesting.
and then it's a little bit less, a little bit less, a little bit less, 0. So to me, what I would say is, it's 4 minus
You said 2.
this, 4 minus x squared. They would all be 4 if they went down to here, but they're getting subtracted by wherever x squared is. And then you can test these couple points. If you plug in 0 for x, you get what you need. You plug in 2 for x, you get what you need. And then you can have a little more confidence.
Checking it. Spencer. Hi.
114.
You guys are done with the 114?
I'm pretty sure this is right. I'm almost 20% sure like this is.
I know this is.
I haven't gotten 32 over.
Again, I just updated the website. I'm sorry, I thought I already had this on there, but this circuit has every question worked out except for number 14 and 15. It also has some extra practice if you feel like you want some extra practice. So, it's on there.
That's
You're talking about areas,
Mhm.
and you're telling it to find x squared. Is it talking about the area above or below the graph?
It depends on what you're rotating it around.
If you're rotating about the x-axis.
Okay, so if you take this area and you rotate it this way, this is kind of what your 3D shape would look like.
Yeah.
So if you draw these, the circles that connect those would be your cross sections. And then this would represent R. So in this case, R should be whatever this length is, which is x squared.
Okay.
But that's not going to be the same every single question.
So here, that makes sense doing that, okay? Squared. Yeah, like that.
Yep. That looks good to me.
Got it.
Wait, except
Would it be divided by pi?
the region. Okay, there's actually one mistake here. Is this what x squared looks like?
14.6 pi.
It's like,
He also goes here.
yeah.
So the area is actually all of this. So you shouldn't be integrating from 0 to 2. I think you should be integrating from -2 to 2.
Let's say it's bounded by the y-axis.
Oh, okay, my bad.
Okay.
I didn't read it carefully enough.
Okay, but you're saying it only it depends whether it's not whether it's talking about the x-axis or y-axis, whether what the x word would mean, like what area it would
I'm just saying
represent.
that you need to be really careful with these radius lengths.
Okay.
Because the way you were saying it was x squared, I didn't know if you were just guessing it was this and hoping that that was right. You should actually be thinking about those circular cross sections. Because if you draw a couple of them in, you can see what r is. Sometimes r is going to be equal to y. Sometimes it's going to be equal to 2y. Sometimes it's going to be equal to 4 minus y. It just depends on the setup and where you're rotating it.
Got it. Thank you. Yeah.
No, they're not. I literally only did that for that. Was it answered? Sure sounds good.
How do you find the big radius of this?
Are you rotating?
-3.
Okay. We'll draw a cross section. Draw a couple of circles. And take a point. Okay. So that's going to the outside points. And this would be your big R. So to me, that's whatever this length is. 3, I guess, plus whatever that is.
So you said it equal to.
Yeah, so it's 3
Does it say?
plus whatever x squared. No, because it changes right here, it's a lot smaller than right here. Because this is
So it's 3 plus x.
You're always gonna go
Yeah, I
from
got
here
it.
to unless you're gonna go up wherever x squared was. That would be your big R.
So the boundary for 4 to 0.
0 to
0 to 3, right? So then the big
why then you 15. Because usually the ones at the end are a little hard, but they usually build you up.
It's just like
I don't know too many. I don't know many. Usually it's a math teacher.
wait, okay.
There's enough for that. Plus these are like, again, it's not just, it's like I'm saying, here's some more questions back. It's like, question 1 is like, basic,
Yeah, there's a
kind of understand what you're doing. And then the second question might throw you the surface factors. And the next question might throw you like every question kind of input. And that takes a lot of thought to come up with good questions that are just slightly different. Yeah.
So what was your
That's a lot of work. It would take me a few hours to come up with good questions. And also they usually do it where like, if you make a common mistake on question 5, it'll be one of the answers, but it's not the right answer. Yeah, so then, you know, kind of, it's better if you do that. It makes people really analyze what they did wrong later.
You're not on number 7?
You said you have 11.
I did, but none of the numbers on our 7.
Visualizing. Number 10. I did it wrong the first time. That's when I make sure everything's the picture.
Make sure it's fine to me. I have that as number 15.
Oh yeah, that's 15.
Wait, so was I right? Wait, what's the answer to 6?
Yeah. Well,
What'd you say?
oh, it's rotating that way.
6. What did you get for it?
A different answer than them?
I got 32.
Bigger.
I guess I'm still wrong.
I
It's fine.
But it's a lot.
So 14.
6 plus x squared.
Sorry. This is my 14. That's your 14. But that's the right answer.
I think smaller now.
So it's probably number 8.
I have that as number 18.
You have 8, 2, 7.
Then it
And
must have just.
That's that number, so that definitely fits what we're doing, so that'll be subtracted. Because again, anything else is 7 smaller than that.
that's supposed to be the last one, so I didn't write the answer down, but it should be. Oh,
Seven, right?
It must have died somewhere.
You did 7.
I must have.
I've been out sick. What? No? Extra spring break? You don't remember?
Wait, sorry, were you asking why you had this?
No. I asked if you were sick last week.
Oh, yeah.
Okay. Sick from spring break?
I'm at 7,700.
So you were sick for like 2 weeks?
Oh,
Saturday, after the it's like the
So it's time to go back to school, you guys. That's what it was.
Like, it wasn't COVID, it wasn't the flu, but.
It was I want to stay home.
Okay, so, because this part is the big radius.
Yeah, so it's 6. 6 minus.
Oh, I actually recorded it.
Because when x is 0, the radius is 6.
Okay, so it's 6 minus x. I think I can get it. I got 192.
It's farther from this than this.
I think the small radius.
Yeah, that's just like
It's 4 times x squared, that's something.
Oh wait, I think the small radius is 6.
because it has the
4x. Because you have to subtract this and that's bounded by this and that.
Yeah,
So,
Grace is right.
so let's say x is 0, then that means there's just 6. Yeah, okay. So 6 minus.
So it's the first radius is 6 minus x squared, and the second one is 6 minus 4x. So the other. Because it's like, okay, so this part is big radius. Like if you ignore this thing, it's this part, this is the big radius. And then if you subtract that by this x squared, which is bounded by this one, you know, this is 4x minus x squared. So you have to subtract this part, like this was the big radius, and you can get an area bounded by these two.
Yeah, no, I'm not good at that.
No, not right now.
It's 64 there.
Yeah, that's
I just got 128 straight. How did you blink? You got 128 we're talking about. Or did I do the? You got 393.
Grace is right.
Yeah, I think it's useful.
Oh, yeah, because there's a reason why.
So we have to solve for x.
Oh, yeah, you just solve it. You just set it to one side. But you have to have it in first of the block.
Yeah, you just pull everything to the other side. Yeah. So I'll be like, 2, 3. Like this.
Yeah, that's what I go. Wait, hold on.
Oh,
No, you said it, you said you have to solve for x. Because that's how. Yeah, I got the same answer. Because you have to have it in terms of y specific. I think you did it. You did it.
Start making the drinks better.
Oh, I see.
JC?
No, not JC. Well, not as loud.
You have -2/3 y minus 1. Or wait. Because you have.
It's worth it though.
Yeah, never mind. My bad. Yeah. Did you get 4?
I'm not 176 over 5.
So what?
Did you get, what did you get? Something I lost.
What is just be 2 times? Because it's like.
So the big one is 4 squared. Oh my god. And then it's only 4 minus x squared. Because so x is 0.
Oh,
But it was just.
Oh, we did it opposite.
I got 1.65.
So then if you had it like this, 4 minus x squared, then x is 0. That means the radius would be 4, which the radius is 4. So the radius of this is It's like,
That one.
so we originally had this one x equation. So
I got 1.6 straight up.
if you plug in 0 like right here, the radius would be, we're saying the radius would be 0, but the radius is 4, and it's being rotated out.
Yeah.
So that means.
I got -35.2.
Make sure when you plug in 0
Oh.
equals 4.
I think it's.
So then
I
when
think it's
one,
2 times the square root of
when
y.
x equals 1, it used to
Yeah,
the
yeah.
radius is 0 as it's going up, that's why it's 5.
What?
I did 0 too.
Oh, wait, I did it wrong. Wait, no, do you not do the bounds of y? Did you get 8 over 5 pi?
I got 32 pi.
Yes.
It's not.
There it goes. Wait, take off the two.
Not 8 over 5.
That would be 16 pi.
It's not.
Or wait.
That's what I got.
That's what you got.
You got it wide. You put 4 down.
Oh, wait, hold on.
I thought it was 2, but I thought it was the X, right?
Yeah, it would be x because it's in terms of x.
I thought it was right, but then either way it's wrong. Doesn't matter what percent.
You tried this.
Oh, you're so right.
Or, I guess it's square root of what?
Square root of y, it's supposed to be half of this. But that can be, but then you gotta just be able to
Did you not
straight
get it right,
line,
Sandy?
because square cancels it, and it's not straight. Well, if it's 4, then the
25
Because
times
why
6.
means rotating
I don't know.
around you have to do small y equals sometimes. Y so dy you rotate around y equals to u is something.
I don't know. I'm just trying to
It's in
get.
terms of dx, right? That's a dy. Dx. What we did was a y. I think it hasn't changed. What is it? What is it?
That's not good either. It might just be.
Oh, yeah, you will. Just right. Because it was different. I don't know how, but yeah.
Is it?
Oh, yeah, it's just,
Wait, can I see?
It's just square root without the 2. Yeah.
Wait, is it just y dy?
Yeah. No, it's the one with the.
You're good. That's okay.
Yeah. I know, that's where you just came from.
Wait, that's 6.
So the bigger you see.
I feel like 6 is wrong. No, you literally said that's right.
6 is right.
Yeah, it is.
There.
And then the small is 1.
So what were your bounds?
It's gotta be this one.
Because it's by the y-axis, so it has to be just the y.
So it's just 0 to 4, and then 6 or just 1 square.
140.
So it's just 6 squares
Because that's the So 0 to 3.
It's the X, right?
You want rotating you want. So the far one is the biggest radius is the middle one.
Really?
Big thing for you, Chase.
You are in all spots.
Because it's actually minus 7.
So plug it into y equals.
I got 40.5, which is 81 over 2.
What's your, oh, there's only one, there's only one R, right? Yeah, it's just gonna be,
I mean, there's always one R, if
y
it's not
squared.
rotated over.
Yeah, a certain,
What's in terms of
yeah, so just do, this side.
Yeah, there's not any space between.
And you got,
81 house. Which is the last one I had. Or like, not the last one.
what number is that?
60. 10. Oh,
16.
yeah. Sorry. 29.
Yeah, we have 17, 18 going.
You should at least figure this one out.
We should at least figure this one out.
Something with giant feet in this space.
There is also only one R for this one. Zero to four.
But it's,
Wait, no, that's.
You're not allowed to.
Wait, yeah.
yeah, I think
Wait,
it's.
It's DY.
It's the same line, right?
It's a there.
It's 0 to.
Is it 2 minus? Oh, it's in terms of water.
Well, I do want to there, but I think it's not about like making it. It's about
Something's pretty.
and then having it this
Who? Oh, wait.
It's getting smaller, he's telling me it's like the radius. Getting smaller. Oh yeah, yeah, it's getting closer to the line.
Would it be?
Yeah, that's what
Yeah.
Well, the lines are like
No, there's one. So it should be
That's an answer.
yeah, that's all we had to step out with that. Yeah. We did that.
Do we solve?
Yeah, we solved 18 and we solved 17, so we're done.
So this number 116, the part 1.
Part 1.
You already did Friday?
Yes, that's 116.
Okay, thank you.
Is that what we did? Is that what we did? It's the same thing that we practiced today. We just did part 2 today, so it's the same question types. I just doing more practice.
Did you find this?
Yeah, that wouldn't be right. That's 1.1.
No. We did the front page together, and then about the
Okay, we are down to about 5 minutes here, so let's make sure that you know what's expected of you next class. So, you should have 116 finished. You all should have done that before you moved back to 114. This is the 3rd time I've given you class time on 114. So at this point, if you don't have that finished, I need you to do it for homework. And I did just post the help videos today, so all but 2 of the questions are up there, so that should help you with whichever ones you're struggling with. And then of course, oh, I'm sorry, I'm looking at the wrong one here. There we go. And next class, the mini quiz, derivative of inverse trig functions. There won't be any chain rule, no applications of them, no plugging in numbers, just have you memorize them. 2 of them you need to be able to write them out, the other 4 you need to be able to match them. But not meant to be a trick at all, but just make sure that you know that. And then I guess that's it.
replacing some of the with mayonnaise. That's not fun. They just take a spoonful of mayonnaise. I haven't really seen anybody eat. Yeah, I know when it's from grandma.
Oh yeah.
I thought it was all the way here. Replacing some yogurt with mayonnaise.
That's fine.
I think maybe if you had a cup of yogurt, that you had.
Oh, wait. Wait, it's actually really bad. It looks like
By the way, I have 106 and 107 for you. I had to turn those in earlier.
Okay, I don't remember what those were. You should probably put them.
I don't know where you want me from.
106.
Hospitals roll and area between curves.
Okay, well, you're missing one on this.
I am.
And late work has to be completed, so you need to finish that one first. And this one doesn't have your name on it, so you need to get your name on there. You just put it in the homework box over here. But you need to finish that other question before I give you points on it.
I didn't even notice that question.